Thank you so much. I will try to switch to English. So today I bring here some use cases from the Japanese market. We are working for software developer companies and for end users as well. I will highlight some topics about the machine vision, IT collaboration, sport, research, supercomputing, and some of the results. First of all, it will be a project about OCR, how it is bringing to the IT market nowadays, how can solve different teamwork and the multi-language issues. So first of all, we are working for different software developer companies, and we realize that there are so many great projects in Japan, but we could not bring to the Hungarian market because of the language issues. So everyone talks in English somehow, but if you are talking about the Japanese language, then the context sensitivity, it is quite interesting topic, and we could not understand each other properly. So here is a conference call where we have users from Japan, Hungary, Taiwan, and we try to understand each other. But there are several other type of topics where we use Mandarin and Spanish and some other languages connected to those topics. And here is the main issue that we try to solve. So how was the human translating before the COVID? We tried with face-to-face communication to solve all of these issues by using human translators, but we have to provide all of the PPTs before the sessions. But what happened when there were some unexpected features, or we changed the topic, or we went into the detail, then it happened quite big misunderstanding. So the improvisation it doesn't work in this way. There were some communication gaps. We could not understand each other, and that caused that it was expanded the preparation period. After that, we realized that okay, but we have the possibility not to use the chatbot, but maybe the human translators can solve these issues. So we have different teams speaking in different languages, but we have the English, the common language, we can use it. Unfortunately, this was not working when we had the topic with the Japanese teams, because their English level was not so proper. So actually, we missed the information there. And after that, we tried to realize some multilingual real-time teamwork topic, where there was some issues about the dialects used by the same teams. The translation between different languages was not so good, and we missed the real-time communication issue. So here we saw that maybe we should omit the human translators. And we prepared for one of our Japanese software developer customer, pipeline to use AI. So that means that we have some sources directly from the screen. We make some image manipulation. After that, we are using some OCR. We are making a translation. At the end, we have the translation box, and the only topic was here if we can prepare it in real time. So the latency was the biggest issue of us, because all of the technological topics and all of the frameworks, all of the models were available at that period. Here is an example how we are talking with different customers. You see that in the background we are using Hungarian framework. Basically, here is some topics in English, some in Japanese, and we try to understand each other by having this kind of translations there. We tried non-end-to-end and end-to-end models as well, because of the different type of languages and character recognition. We are talking about the Japanese language, where we have 9,400 different characters. So we have a huge vocabulary, and if you are using that vocabulary, we have both type of models here. what kind of real-time OCR we use or recognition. So actually we tried the YOLO. I highlight here just the complexity of the model, because in industry we are using different models and different solutions. We are not using research. So research it's another type of domain. But when we are talking about the AI, you have to know that AI doesn't exist without research. So even though there were available YOLO 5, YOLO 4 at that time, we had to have around 3 months of research in order to set properly the hyperparameters. After that, we tried the Detectron. Here we got much better results. So when on the YOLO was everything so slow, on the Detectron we realized that it is much faster, and then we got much better results. At the end, we tried the transformer-based models, and these gave us the most reliable results. So at the end we had a simplified pipeline where we used AI with Google Translate at that moment, and you can see that here we can talk about basically a real-time, almost real-time pipeline, where at the end, by having a chat with different teams, the Slack, it is translated almost real time, and you can talk or you can have your chat in your own language. But the issues appeared when we started to realize that the Japanese language is context sensitive, so sometimes different context inside the context gives totally different outcomes, and it is quite confusing. So we had to think about how to use a much better model here. And then we choose Pedal OCR. That's a solution for managing Far East languages together with Anglo-Saxon and Latin languages, and we tried to use that one. But we realized that in our infrastructure, one training it takes around 1 year, but we had no such a time. So that was the point. We had to move to the HPC environment to see how we can shorten this period. So we had this kind of opportunity to try out how is the life on the HPC level, but the way of working was totally different. So we prepared synthetic data with training, after that evaluation, fine-tuning, and so on. But in HPC environment, we got totally different kind of approaches. So there we could not use own script, enhanced tools, and Pedal OCR. We had to rethink the whole architecture. And some short feedback about this project. When we are talking about the OCR solution, how can it be used nowadays in industry or in the end user side? We realize that the Latin languages with Anglo-Saxon, it can give a quite reliable solution by using real-time OCR solutions. But if you combine it with the Japanese language or with the Chinese one, then it is not enough, this kind of solution. So you have to think about how to cut the vocabulary from the 9,000 to the 4,000, and to have a specific domain-specific language, and to train a model for that domain-specific language, because in this way you will have a dedicated language model, and that language model will serve that kind of communication with different teams. About the corpus and dataset, sometimes we had to screw up the good corpus, because it gave us much worse feedback than we expected. And here came out the garbage in, garbage out approach as well. I think that some other presenters we talk about. So sometimes you have to be very careful about how to create the data set, but you have to add inside some garbage as well in order to get a higher accuracy than is expected. We had different issues with single line versus multi-line detection, talking about the OCR solutions. If some of you manage this topic, you have much more details about that. How to set up the different type of models properly, how to set up the different type of hyperparameters, what was already a challenge. And currently, we decided to move to the next step here to combine the generative AI into this solution, because we realized that the context-sensitive language, if it's combined with generative AI, it can give a much better approach. Talking about the software development, so we don't know any other domain, but talking about the software development, it is a good approach to try. I try to bring here two other very short, briefly information about the sport field. How to extract the strategy from different videos in a sport field. So basically, we created a data-driven decision-making model. You have to know that we have a cooperation with the Japanese Ice Hockey Federation and Basketball Federation, and we have quite a strong connectivity with them. They are making some videos, and from the videos they try to extract the strategies in order to have much power in order to prepare for different competitions. And what we did here, we tried the YOLO to extract the position. After that, we use this model not only to extract the position and to show the strategy, but here are some outcomes. And this is the most important thing, that they have recorded videos. From the recorded videos, we are extracting different patterns. We are analyzing the patterns. We are preparing the strategies. And we are preparing the drills. These are the strategies which is used in sport. And we try to use in real time in order to have much confidence in comparison with the opponent teams. And another use case what we have, that is also connected to the sport, that is how to detect the different lesions and tumors following the several head injuries. So this was with American football and ice hockey as well. So we can see that really fancy when we are watching in the television, but in reality it's not so fancy. So actually we had a strong connectivity with the ice hockey federation, where they face that they need some pre-diagnosis tool in order to have some information about the injuries. And here you can see in that model that we have the different type of activities, and the different type of activities differ in that way that in some sports they cannot use sensors. In some sports they can use different specific type of sensors, and there are some sports where they can use everything. Everything is in the United States, but coming to the east, they not allow sensoring. So that's why we have to have a solution for that one. And the approach was to prepare a model which is almost real time in order to support the doctors to have information about anomalies or different injuries. Here we use also the model. So currently the latest version is YOLO 10, if I remember. And we tried also to use the YOLO NAS. About the YOLO NAS, we got this kind of feedback that we will need much more data than in comparison with the YOLO. The accuracy will be much higher, but we have to be very careful about how to prepare and how to annotate. So basically, it doesn't deserve sometimes if you are working in a competition sector. We got some promising results, but after that we realized that basically for the anomaly detection or injury detection or simply the object detection, we can support the doctors, with the pre-diagnosis, because sometimes we get totally different outcomes than it was expected. So we had to have a direct discussion with the doctors and physicians in order to understand why the AI gave this kind of outcome, and how can it be understand the results. And after that we start to adjust the model. So here is about the YOLO NAS. Here we got much more interesting or much better result. You can see here an anomaly where different type of tumors appeared, and we had to go into the detail to make a deeper analysis, and basically it was a great outcome or secondary outcome of the researchers. Okay, here is another comparison about the results. So basically what we realized that YOLO on us was much better, but we had to collect much more data, and the much more data, it is not available all the time. About the results, we get almost the same results if we compared on the same level. So here you can see the different comparisons. So basically these were what I wanted to highlight. So what is important then in industry sector or in the industrial field, talking about the AI, in our understanding, it is a tool. So it is not a must-have tool. Sometimes we are using, sometimes not. But what is important all the time, what we are looking to decrease the workload, to increase the capacity, to increase the outcomes, but we are not using all the time AI. We are using AI as per need and as an additional tool. And talking about the human lives, we have strong connectivity with doctors, physicians, and all of the team members, and we are discussing all the time about the results in order to understand why this kind of decision-making process happened on the AI side. Because sometimes, like teaching kids, it's totally unexpected what should it be resulted. Thank you so much.